Hello everyone, welcome to this video. In this video, we'll be solving this question which states that if G be a group of functions from R to R star where the group operation is multiplication of functions, right? So basically the group operation is function composition, right? So what is this group? This group contains all the functions which start from whose domain is the set of real numbers and whose range is all the real numbers except the number 0, correct? So this group G, this set G forms a group under multiplication of functions. This is given to us. Now if we take some subset of it, H, which is what? Which contains all the functions f from G such that when you input 2 into it, you get 1. This is the condition. So we collect all such functions and put them in H. Now this becomes a subset of G. Now we have to prove that this H basically is a subgroup of G, right? So here how can we proceed? We can either use one-step subgroup test or two-step subgroup test according to our will. So here, in order to prove that H is a subgroup of G, I am going to use two-step subgroup test. The test is like this: if G is a group under the operation of multiplication, right, function multiplication, and H is some subset of it, then H star, this forms a subgroup of G star if and only whenever it is non-empty. Whenever if AB is contained in H, then A star B should also be contained in H, and whenever A is contained in H, its inverse should also be present in H. So let's start with the first step. Here, what is the identity of this group G? Let's identify that first. What is the identity here? It is the identity function I of x, which when multiplied by any function give you the same function back, correct? So that is there. So we know that the identity of G is the identity function. What kind of identity function? Such that this is the identity function, right? So we say we name it by I of x. We say this I of x is also present in H. Why? Because when you input 2 into it, you are going to get 1. So basically we are defining this to be the constant function 1, correct? The single digit 1, as I of 2 is equal to 1. So this belongs to H. Therefore from here we obtain H to be non-empty set. So this fulfills our first condition. For the second condition, we consider two functions f of x and g of x in H, correct? So what does it mean? By the definition of H, it means that both f of 2 and g of 2, they are equal to 1, correct? This is by the definition of H. This is how we have defined H here. Okay, so therefore we wanted to check whether A star B is also present in H. So let's have a look. So f of into g of 2, what would it be? It would be f of g of 2, right? You can apply the bracket. So what is g of 2? G of 2 is 1, so you get here the answer as 1, correct? So basically it is not like this. This is not function composition, it is just function multiplication. So it would be f of 2 into g of 2. Your f of 2 is 1, your g of 2 is 1, so this also come out to be equal to 1. Hence f into g, this is an element of H, correct? So this proves our second property. For the third property, if we take some function f of x in H, we wanted to prove that this f inverse x is also present in H. This is what we want, correct? You can write it like this: the inverse of this element is also present in H. So for this, you know, every function has its inverse. So you have this as equal to the identity element, which is x, correct? Now if you put x is equal to 2 here into this expression, so you get f of 2 into f of 2 inverse correct, is equal to I of 2. So I of 2 is 1, you know, being the identity function f of 2, because f is present in H, is equal to 1. So from here you obtain f of 2 inverse is equal to 1. So that means f of 2 inverse is also equal to 1. So that means this f inverse is present in H, and this is what we wanted to prove here. So I hope you understood this part of the proof well. Correct. Now the second part of the result here says, can 2 be replaced by any real number? So can you pause the video and think for the answer? My answer is yes. The number 2 could be replaced by any real number. Why? It is because, you see, is there any role of 2? As such, there is no role of 2, because here there is no implication or outcome if we change this 2. All the steps are going to remain the same. So this does not affect whether we take 2 here or 3 here. It is according to the condition that we apply on H. Whatever is the condition that we apply here, the same goes in the further step. So the number 2 here does not matter in this particular case. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.